Students, here we are discussing about the complex integration by using Cauchy's integration. There are two types of Cauchy's integration theorems, Cauchy's integration theorem and Cauchy's integration formula. Cauchy's integral theorem says about the analytic functions. Cauchy's integral formula says about the function where it is having singular points also. Students, let me explain Cauchy's integral theorem. Cauchy's integral theorem says that if f of z is an analytic function in and on a closed curve C, then integral over C f of z dz is equal to 0. So, if it is an analytic function, then its integration value is 0. What do you mean by an analytic function? Analytic function means it is derivable at the point and also derivable in some neighborhood of the point. So, in some neighborhood of the point, if it is having a derivative, then we say that it is an analytic function. I will give you an example on which we will use Cauchy's integral theorem. Suppose we want to find integral over c z square plus 5z plus 6 upon z minus 2 dz, where the curve is given as mod z is equal to 1. This means that we have to integrate only along the curve mod z is equal to 1. Now, here the function numerator is z square plus 5z plus 6, which is a polynomial in z. It is analytic everywhere. It is having a derivative everywhere. And similarly, if you consider denominator differently, if you consider the denominator independently, z minus 2 is also analytic everywhere, but when you consider z square plus 5z plus 6 upon z minus 2, it is not analytic at z is equal to 2. Now, the point is that z is equal to 2 is not a point which is lying inside the curve C mod z is equal to 1. Z is equal to 2 is a point which lies outside the curve mod z is equal to 1. Here we have to integrate only inside and on the curve. So, z is equal to 2 is a point which is lying outside, which is having which is not analytic. So, we do not bother about z is equal to 2. The existence of z is equal to 2 inside, because z equal to 2 is a point which lies outside the curve. So, at all the points inside the curve, the function is having a derivative being a polynomial. At all the points inside the curve, the function is having a derivative being the polynomial, because every polynomial is having a derivative. Now, how do you check out whether the point is lying inside or outside? Here I am not drawing a circle, I am just substituting z is equal to 2 in mod c z is equal to 1. So, what I am doing is, so therefore, z is equal to 2, if you substitute it here, mod 2 is equal to 2, which is greater than 1, which lies outside the given curve C mod z equal to 1, hence its integration value is 0 by using Cauchy's integral theorem, because it is completely analytic inside mod z equal to 1. Now, let me explain what is Cauchy's integral formula. Cauchy's integral formula says if f of z is analytic inside and on a closed curve C and A is a point inside C, then f of z upon z minus a dz is equal to 2 pi I into f of A. So, what does it say? If the numerator is analytic inside and on a closed curve C, and the denominator where z minus a is a point where the denominator is turning 0 and this point is lying inside the given curve C, then its integration value is 2 pi I into f of a, that is 2 pi I multiplied by the numerator where z is replaced by a. So, its integration f of z upon z minus a dz value is 2 pi I multiplied by the numerator where z is replaced by a. This is when the denominator is z minus a. So, here we have some points. Here z is equal to a, the analyticity fails, because f of z upon z minus a, if you substitute z equal to a, the denominator is turning to be 0. So, the derivative does not exist. And here the other point is we have to consider a is a point inside C. If a is a point inside C, then we apply Cauchy's integral formula. A is called the singular point or pole. This point where the denominator is turning 0 is called singular point or pole. If you are getting the denominator is 0 for a point inside the curve, then we get the integral as above, that is 2 pi I into multiplied by the numerator where Z is replaced by A. A is a point which is obtained by denominator is equating to 0. So, here we are discussing about different forms of Cauchy's integral formula when the denominator is Z minus A, when the denominator is Z minus A whole square, when the denominator is Z minus A whole power 3, when the denominator is Z minus A whole power 4, and when the denominator is Z minus A whole power n plus 1 generalization. So, when the denominator is Z minus A, we just multiply 2 pi I into the numerator and Z is replaced by A. If the denominator is whole square, then what are we doing? We are multiplying 2 pi I into the derivative of the numerator, Z is replaced by A. If the denominator is whole power 3, then we are multiplying 2 pi I into 2 times the derivative of the numerator and Z is replaced by A. If the denominator is whole power 4, we are multiplying 2 pi I with 3 times the derivative of the numerator and Z is replaced by A. If the denominator is Z minus A whole power n plus 1, then we are multiplying 2 pi I with n times the derivative of the numerator and Z is replaced by A and divided by n factorial. Now, here I will tell you how to check the point is lying inside C and outside C. First thing is, if the point lies inside C, we use Cauchy's integral formula. If the point lies outside C, we use Cauchy's integral theorem and its integration value is 0. Now, how do you find the point is inside or outside? As we all know that Z is a complex variable, it is represented by x plus iy. Its standard notation of complex variable Z is equal to x plus iy. So, if you consider its modulus, modulus of Z is equal to under root of x square plus y square. Modulus of Z minus of a plus ib. Suppose you have any problem of this kind, Z minus of a plus ib, then what shall we do? We write Z is equal to x plus iy minus of a plus ib, then you write minus a minus ib, then take real part and imaginary part separately. Modulus of x minus a plus I into y minus b. So, modulus of a complex number, how do you calculate? Under root of real part square plus imaginary part square. So, under root of x minus a whole square plus y minus b whole square. So, this is how we find the modulus for any complex number. Then after finding the modulus, what shall we do is we shall calculate its value and compare with the radius given. Compare with the radius given. If its modulus value is less than the radius, then the point is lying inside C. And if the modulus value, calculated modulus value is greater than the radius, then the point lies outside C. So, without drawing the diagram, we can easily say the point is inside or outside. Just calculate the modulus and see, compare with the radius. If it is less than the radius, then it is inside. If it is greater than the radius, it is outside. I will take a question from AKT University, which was given in 2010-11. So, the question was, state Cauchy's integral formula, hence evaluate integral over C e power I pi z upon 2z square minus 5z plus 2 dz. Along the curve, C is the unit circle with center at origin and having positive orientation. Positive orientation means counterclockwise direction or anti-clockwise direction. Unit circle means radius is equal to 1. Center is origin. Now, here let us take the given function as f of z is equal to e power pi z upon 2z square minus 5z plus 2. Now, let us find the roots of the denominator. 2z square minus 5z plus 2 is equal to 0. So, how do you find the roots for this? Minus b plus minus under root of b square minus 4ac upon 2a. So, minus b is minus into minus plus 5 plus minus under root of b square 5 square minus 4ac, 4 into 2 8, 8 2s are 16 upon 2a, 2 2s are 4. So, it is 5 plus minus under root of 25 minus 16 is 9, under root of 9 is 3. So, 5 plus minus 3 upon 4. So, it is 5 plus 3 upon 4 and 5 minus 3 upon 4. 5 plus 3 upon 4 is 8 by 4 is 2, 5 minus 3 upon 4 is 5 minus 3 is 2 upon 4 is 1 by 2. Now let's come back to the problem. The problem was to integrate along C e power I pi z upon 2z square minus 5z plus 2 into dz. Now integral over C e power I pi z, take 2 common from the denominator because we have to make coefficient of z square is 1. So we will take 2 common in the denominator. 2 into z square minus 5z by 2 plus 2 by 2 is 1. Now after taking 2 common in the denominator, now we have already found out the roots of this equation. So we have found out that z is equal to 2 and z equal to 1 by 2 are the roots. So now you can write it as z minus 2 into z minus 1 by 2. So this is a formula whenever you have an equation of this kind, ax square plus bx plus c. First you take a common, then the roots of ax square plus bx plus c are alpha and beta. Then you can write it as a into x minus alpha into a x minus beta. So therefore, because 2 and 1 by 2 are the roots of the equation, so you can write this as 2 into z minus 2 into z minus 1 by 2. Now what shall we do? We have 2 points in the denominator, 2 and 1 by 2. There are 2 points in the denominator where the function does not exist. So if you substitute z equal to 2, it will not exist. If you substitute z equal to 1 by 2, it will not exist. So what shall we do? We will write one factor in each time, at each time. One factor at each time. Z minus 2 one time and z minus 1 by 2 one time. So what shall we do? We write z minus 2 in the denominator once and z minus 1 by 2 in the denominator the second time. So integral over C is divided into 2 curves. Integral over C1 plus integral over C2. C1 is having a denominator z minus 2 and C2 is having a denominator z minus 1 by 2. Now whatever we do, we should not change the question. Question should remain as it is. So when you write z minus 2 in the denominator, the rest of the terms we will take it to the numerator. Similarly, when you are writing z minus 1 by 2 in the denominator, the rest of the terms we will take it to the numerator. Here you can take 2 also in the numerator. Okay. Now given after dividing this, we will see whether a point is inside or outside. We will see the points are inside or outside. The points are 2 and 1 by 2 and the given circle is unit circle, that is mod z is equal to 1 and center is 0 0. So just simply check whether the points are inside or outside. Substitute in the given curve. 2 and 1 by 2 are the points. So mod 2 is equal to 2 greater than 1, 2 greater than 1 lies outside and mod 1 by 2 is less than 1 lies inside. Just compare with the radius given. Given radius is 1, unit circle 1. Now the equation 1 becomes, equation 1 means the integral along C1 plus integral along C2. So integral along C1 which is having z minus 2 in the denominator, so it lies outside the curve, so integration value is 0 plus 2 pi I into the second one is lies inside, so we use Cauchy's integral formula, that is we will multiply 2 pi I into the numerator, replace z is equal to 1 by 2 the point. So 2 pi I into e power z equal to 1 by 2 substitute curve, z equal to 1 by 2 minus 2. So 1 by 2 minus 2 is 1 minus 4 is minus 3 upon 2. So 2 goes to the numerator. So it is e power I pi by 2. So minus 2 pi I, this 2 and this 2 will get cancelled, minus 2 pi I cos e power I pi by 2 is e power I theta formula cos pi by 2 plus I sin pi by 2. Cos pi by 2 is 0, sin pi by 2 is 1. So I into 1, so 2 pi I into 0 plus I. 2 pi I into I square is minus 1, minus into minus plus, it plus by 3. So it is 2 pi I by 2 pi I into minus 2 pi I into I is plus 2 pi by 3. So answer is 2 pi by 3. Now here is a homework for two problems I gave you.